Thank you. So now we have a duet by Claudiu and Antonius who will present on the HIPAA cloud, private cloud. So.
We'll skip the introductions because we're 1 minute late. Um, so we'll talk about the infrastructure first, what we have, go through a typical scientific workflow and analyze why it's difficult to move from a typical scientific workflow into the cloud. A little bit about the IDESH cloud and what the shade is all about, how we can achieve repeatable results with this one, and of course status and future plans. So a little bit about what we have. A lot of hardware, of course, virtualization on top so that we can make good use of the resources that we've got. Then we carved out of these two separate environments, the enterprise and the cloud. The enterprise is again split into two, the PHI and non-PHI environment. Into each of them, in the enterprise environment, you have more stable, reliable resources that you can use for PHI repository, websites, and so on. Whereas in the cloud, everything is more ephemeral. It just comes and goes. Projects on various type of data start at one point, do some number crunching, they get terminated, and resources are reallocated to other projects. Of course, this is all protected through a lot of firewalls, VPNs, two-factor authentication. Antonius will mention a lot of them in the next slides. So let's look at a typical scientific workflow. Let me start with this. It's typically complex and it takes a lot of time. So you have an idea, you start with some raw data, it's in a red, you're doing some incremental refinement until you have something that is publishable, the green stuff, and you think you have nailed it down after a couple of iterations, and this becomes internal knowledge in one of the labs. You typically put it together, and this is the workflow. And there is a complex stuff which is no longer so complex in your lab, but it's still complex for the outside world. Now, if you're looking at the cloud and you say, okay, I have this thing, and now I want to share it or publish or maybe make a business out of it. If you're looking at the cloud, there are three levels of abstraction that you have to think about. The bottom layer, infrastructure, on top of it, platform, and really the top, software as a service. And where can I put these things? Well, the tools go really at the lower level. The tools are typically just handcrafted for desktop or for servers. There is not much you can do about them. It requires a lot of insight into how they work to be able to use them. But the workflow is actually what is interesting for the rest of the people, clinicians and end users that will actually take it and run with their own data. So the question now is, I have this, can I go to the cloud or not? Well, the first thing is, as I mentioned, the applications are not designed for the cloud. In the best case, they are designed for a cluster and nothing more. There's nothing at the platform of, as a service level. That means there is no API that you can use to FedEx your data or publish it somewhere. There's not something like that. Most published work actually uses Amazon Cloud because it's cheap and it's there. Privacy and security are an afterthought because the people that are doing it are not really trained to thinking this way. And data still goes around with, again, unencrypted FTP. In the end, the end-to-end analysis are really hard work because even the latest published work works well with their own test data. If you take it out of the context and you want to use it with your data, good luck. It takes hundreds of emails with the developers to actually get it running. Yeah, that's the reality. So what we did, and we are trying to actually help the community, is fine-tune these things, get them working so that we can actually share with the rest of the world. So we have a cloud compute that you can allocate resources like memory, storage, networking for all kinds of projects. In their shade, there are a number of repositories that allow you to put PHI and non-PHI data, but also tools and recipes such that you can interoperate and run your data and your analysis in the cloud. In the end, hopefully, we hope that end users can run and publish their work with others and get credit for that. For that reason, let's see how we can do repeatable results using the IDESH cloud. And trying to provide an answer of how can you share and get a credit for that. So what's the incentive for you? And of course, how can you propagate this model and get others to buy in? So let's start first with Jane, who has a workflow that she wants to make available because she got her paper accepted in Nature Genetics. Another user, of course, Mary, reads about this in Bright Bulb, Energy Star, of course, turns on, so I would like to use that thing. Now, how does it work? So this is where IDESH comes into place with this environment. We actually have two missions, one to help Jane publish and get her rewarded for publishing and taking the effort of doing it, and of course getting Mary to be happy about using a product that is polished end to end. So we take the workflow, we bring it to a context by bringing in the reference database that was maybe used, test data, configuration OS, everything that's necessary so that the workflow actually can work. We make it into a blueprint and we put it into our bookshelf on top of our repositories. So now she gets a star because her thing is now something that others can look for. It's valuable. We tried it with some data that is there already. It's not something that was just published. It's on a piece of paper. It's actually something that somebody can look for and use it. So now our users deposit data into our repository for PHI or maybe in a third-party repository. And now, when they're looking for that specific recipe, our Jane user gets another star because a view count. Somebody is looking for her specific recipe that matches a specific idea. Going forward, again, this is something that we are developing to make it even more polished. As soon as the end user sees this recipe, she can go and say, oh, I want this. So at that moment, it's instantiated into our cloud, and the instance now is completely contextualized as it was before, but again with the test data. It gets populated with the input data, and upon execution, the results go back into our repository. At this point in time, our user gets another star because actually the recipe worked end-to-end with the data that the end user provided. Of course, Mary's happy because she got everything smoothly, no friction, her data was analyzed, here are the results. In the end, if she gets to publish in Nature, our end users, our collaborators that actually created this workflow get another star. So that's the credit system that we are envisioning that will entitle end users to put more data in the cloud, put more tools in the cloud, make it easy for something else to take this thing and just go with their own analysis. With this, I will switch to Antonio to specific improvements that we did this year.
So in order to make this happen, of course, there's got to be a certain amount of infrastructure that goes with it. And much of this is a continual improvement and building up on what's already there. I think last year we reported on sort of the base framework of what was in iDashCloud, and now I would like to report on some of the improvements that we've made to this cloud. Some of it is hardware. As you can see, we've ordered and installed additional hardware, 180 terabytes of additional storage using Dell Compellent. This is a tiered storage system which includes SSDs, the solid-state drives, 15K drives, and 7.2K drives for a nice tiering of the data. We added 2 more Dell 920 servers with 1 terabyte of RAM each. This has 4 CPUs per server, and each of these CPUs have 15 physical cores or 30 virtual or logical cores. So there's a nice addition to the iDashCloud infrastructure. We've made significant improvements on software and security, implemented data replication for disaster recovery purposes. We've upgraded to the VMware Cloud Suite 6.0 and have improved VM provisioning automation as well as the user portal experience. We've improved the automation of the storage tiering with a lot of these, with this Compellent edition. At this point, the sort of schematic of the cloud looks as follows. But the summary is that we have 3 computational tiers. They are partitioned between the high, mid, and low tiers, sort of computing farms. We have 3 storage tiers, which are also partitioned between solid-state 15K drives and 7.2K drives. We have 10 gigabits per second connectivity throughout with full redundancy in all the networking. There's a 2-factor authentication that we have also implemented. I think I should point out too, as was mentioned by the VA, we have firewalls within firewalls because we want to be extremely secure. So there's an external firewall that our academic computing and telecommunications unit has for the university. We then, through that is a VPN tunnel. Through that is our own sort of firewall that does a lot of monitoring and authorized access. And then we have 2-factor authentication to get into the actual PHI data. There is also remote data replication, as I pointed out in the previous slide, which allows us to archive data for disaster recovery or other research purposes. There's at this point over 800 cores, 7 terabytes of RAM, and over 600 terabytes of storage built into this cloud. So what are some of the future plans? Our purpose, as Claudio pointed out, is to improve the user experience as well as management. So, oh, sorry. I usually have a loud voice, but we also would like to improve the collaborative environment in the whole cloud experience based on the paradigm and the use cases that Claudio described. We intend to do this using software that has been published by VMware called SocialCast. This is something that allows you to sort of have Facebook, Twitter-like collaborative communities, as well as chats that you can establish between different units or different communities that are working together, research groups, and of course integrate that into Shade, which is the repository for sharing data that we've already built within the iDash cloud. We would like to implement seamless motion of VMs. The idea here is that we've got a bunch of data that sits, as we all have heard, in different locations. Everybody's very nervous about the security of this data because, after all, it needs to be HIPAA protected. And so that has slowed down requests for access to actually utilize the data. So one of the new technologies that's come out by VMware is a vMotion. Basically, it's the motion of a virtual machine to another center, vCenter, in a completely different location. We intend to implement this within our environment between the two data centers that we currently have information and data sitting there, and to experiment with how this all functions and how we can actually provide that as a tool to the community. We would also like to experiment with VMware's EvoRail. I don't know how many of you have heard about this, but this is basically a very interesting concept, which it's a hyper-converged infrastructure between hardware and software. In essence, it's a small box that is equivalent to approximately almost a full rack of servers, and allows you to package the VMware cloud, or the iDash cloud in this case, to sort of create these portable units that could be templates for other institutions to utilize. We like to call this cloud in a box. And of course, we would like to also implement sort of the IT business management model, which allows us to monitor how this whole thing is used and how to better improve it in the future. And with that, we'd like to ask you for some questions.
Thank you. So let me ask for us to start switching slides there as from the audience, and Kevin gets ready to come here. So everyone is a little shy today. Not exactly sure.
There's somebody that's not shy down there.
Okay, so we have a question.
Claudio, can you guys hear me? Okay. Claudio, you showed a model of how the workflow can be captured and reused. Per Susanna's talk this morning, had you adopted any particular standards for representing the different components of workflow?
So the issue with the workflows in the scientific world is that there is not one standard that you can just pick. There are so many workflow engines that you can use, and each specific scientific analysis may use one or the other, or others. So for instance, we had experience with Galaxy, but there is also Taverna and a bunch of others. So you can't really say that everybody will standardize into using just one in particular, because that would definitely limit the potential of applications that you can have. In our model, you can pretty much come not only with just the workflow or just the idea or these tools, but an entire suite. If you want 10 virtual machines that would actually represent your application, that is possible.
Thank you. And before we get into nitty-gritty, because I know this technology people get all excited about that.
We'll talk at lunch.
Yeah, I would invite you to do that. Thank you very much.